Hello students, welcome to classroom. I hope you are all doing well. Today we will be discussing a very important topic, and the name of the topic is refraction of light through a prism. So this is a very simple topic, and this involves a prism. So by now you may, if this lesson is taken in the school, then you have a very good idea of what a prism is. And if it is not taken, then I will tell you what a prism is. A prism is a triangular object. Okay, it looks like this. Okay, in reality it will have 5 faces. Okay, one in front, immediately behind, another base that makes it 3, then one here, 2 inclined surfaces will be there. So altogether it has got 5 surfaces. So in diagram we draw a prism like this. Okay, it looks like it is in the shape of a triangle only, and then we use this prism to study dispersion of light and refraction of light. In our today's topic, we will be using this prism to study refraction of light. That means bending of light. Okay, how bending of light actually takes place in a prism. So prisms are transparent because they are made from either glass or plastic, and then the incident ray is made to fall on this inclined surface. Okay, this surface is called the inclined surface. Inclined surface because it's like a slope, is not. Such type of surfaces are called inclined surfaces. The roof of our houses are inclined, which makes water flow easy. Okay, when it rains, okay, the rainwater flows down easily because the slope is inclined. Slopes are examples of inclined surface. So in a prism also we have 2 inclined surfaces, and the incident ray is made to fall on any one of the inclined surfaces. So let us study in detail how refraction actually takes place in a prism. So I will request all of you to open a book, grab a pen or a pencil, and draw along with me, and then we'll learn together. So let us draw ourselves a prism. So I wonder whether I'll be able to draw a triangle freehand or not, but let me try, because only after trying we will know. I don't think so. This is coming out bad. Okay, then let me use my scale. So here is my scale, class. This is my scale. Okay, let me show you my scale. It looks like this. See, what do you think it is? Okay, this will be the question, okay, for today. Please comment this. Identify the object. Okay, I'll show you the front also. It looks like this, reddish here, and on the back side it is somewhat like this. So this is the question. In the comment box you please write down what this is. Okay, please write down. This is gonna be my scale. Okay, because we don't get longer scales, so I'll have to use this. So let's try to draw a triangle using this. Okay, I'll just show you the back side so that it will make it difficult for you to guess. All right, let us get ourselves a triangle. All right, point. This is the easiest way to draw a triangle. So let's do this. One side done. Then what about this? I hope it turns out all right. Another side done. I hope it's all right. It's all right. And then let's just draw like this. All right. How is it? Is it all right? Yes. More than perfect. Okay. More than perfect. We have to do some jugaad. Okay, so this is the prism. Let us give a name to this prism. Let's say this is A, B, and C. All right, so this will be the triangular prism, and these are the inclined surfaces. Okay, these are the inclined surfaces. These are the inclined face. We can write inclined face. Okay, And here, remember class, here this will be the angle of prism. Okay, this is called the angle of prism. Angle of prism. You may not write it, we can always show it. Okay, so this angle of prism is the angle which the prism carries. It's between these two arms. Okay, this and this. Okay, so since it is a triangle, it has got three vertices, one here, another here, another here. Corners. Okay, corners are also known as vertices. So this, you can always show the angle. This will be the angle of prism. Now let us continue into the discussion. So we need to draw a incident ray. Okay, so let us bring one incident ray. Let me use my scale again. So let me use my scale here. Let me show you the picture. I think this is all right. I think this will be all right. So this is the incident ray. This will be the incident ray. So this is IR. This is IR incident ray. Okay, side by side. Okay, this comes for 3 marks, so you have to write some notes also. So we are not going to write a lot of things, just some small information. So on the side, okay, you can always write some information explaining what these are. Okay, this is a very simple experiment, so side by side you have to explain also. So IR, what is IR? Let's write down. So IR will be our incident ray. This is the incident ray. Okay, this is one single ray of light. Then this point, very important point. What is this point, class? This point is the point of incidence, okay, which is on this inclined surface AB. So this is the point of incidence. We can give a name to this also. So let's give a name. Let's say this is K. Okay, we can always give a name. And then on every point of incidence, we draw perpendicular, isn't it? So let us draw a perpendicular. So let me draw a perpendicular on this. I hope it's perpendicular. Okay, make sure that it's perpendicular, class, on your end also. So this is what I will be drawing. Yes, this is the perpendicular, which is called the normal. So this is normal. Let's call it N1. Let's call this as N1. So N1 is the normal. And remember, normal is always drawn perpendicular to the surface on the point of incidence. The point of incidence is the point where the light touches the surface. Okay, we can also call it as the landing spot. Okay, where the light actually makes contact with the surface. This is perpendicular, so we can always write like this. Okay, then now time to draw the refracted ray. See, this is air, this is air, and this is glass. So light travels from air to glass. Light travels from rare to, this is rare, this is rare medium, and this is dense. Alright, glass, this is a dense medium. Is it not? Air is rare, glass is dense. Okay, so light enters from rare to dense medium. Now think, how will this light undergo bending? Refraction will take place. So I want you to tell me, will it bend towards normal or away from normal? Remember, light is entering from rare medium to dense medium. When light enters from rare medium to dense medium, how does it undergo bending? Yes, it bends towards normal. So it will bend towards normal. So it will bend towards normal. So let us make the ray bend towards normal. So it will bend towards normal. So let's make it bend. Alright, so let's make it bend. So this is it. It is bending towards normal. So the ray is bending towards normal. See, it is bending towards normal. This is the angle. Okay, this is the angle of refraction. So angle R. Okay, so angle R, angle of refraction. This is the angle of refraction. Okay, so this is our R. What is RR? Refracted ray. So R is the refracted ray. Okay, then again this becomes another point of incidence, okay, and then from here again the ray will undergo refraction, the ray will undergo, okay, bending again. Now this is glass and then this becomes air again, so this is air, so light will exit to air again, so this is air, okay, air is rare again, so light, okay, light will exit to a rarer medium from a denser medium. So again you have to tell me again, how will bending take place when light enters from dense medium to rare medium? Bending will take place towards normal or away from normal. What is your answer? Yes, this time it will be away from normal, okay, since light will exit to a rare medium, light will travel faster, so this time it will go far away from normal, so this time bending will take place away from normal. But I have not even drawn the normal, so let us draw the normal. So the normal will be drawn perpendicular to this plane again, so let us draw normal perpendicular to this plane. Make sure that it's perpendicular, okay class. If it is not perpendicular, then our discussion will be wrong. So I hope this is perpendicular. All right, let's keep it to the side now. Now perpendicular, okay, and then it will bend away from normal, so away from normal, so this is normal, so it will bend away from normal. I need the scale again, so let's make it bend away from normal, so away from normal, okay. So afterwards I will need another, okay, let's make it like this, so away from normal. So this is the emergent ray, so this is the emergent ray, okay. This is the refracted ray class, and we do not call this as a refracted ray, okay. This will be called now the emergent ray, means the ray which emerges out of the prism. So this is now the emergent ray, so this is called ER. ER means emergent ray, so this is ER, which is emergent ray, okay. And then between the normal and this emergent ray there will be an angle which is called the angle E. And what is this angle E? A very important angle. Angle E is called the angle of emergence. All right, this is the angle of emergence. It is between the emergent ray and the normal. All right. Oh, I forgot. So this is another normal. So this normal, we have to give a name to it. Let's give a name N2. So N2 is also another normal. So N2 is a normal. Okay, so we have one normal here because we have one point of incidence here. We have another normal here because we have another point of incidence here. Okay, so we are almost done, but still some small things are left. Now you see, class, so if this prism was not there, okay, if this prism was not there, then how do you suppose this incident ray will have traveled? Will it not have traveled like this? Will it not have traveled like this? Yes, isn't it? It will have traveled straight, okay. But then because of the prism, how is it traveling? Look, it is traveling like this, okay. The emergent ray looks like this. So what we will do is, okay, we will show the supposed path of light. So let's show the supposed path of light. So let us show the supposed path of light. So let me trace back to my original. So this must be it, okay. My scale is very unbalanced, very unstable, sorry. But then just roughly, okay, I'll just trace it. Yes, this is it. This will have been the path of light if the prism was not there, okay. Then what we will do is, this is the emergent ray. The emergent ray is going in this direction. So what I will do is I will backtrace this also. So let's backtrace this also. So on backtracing this, we will find something very interesting here. So on backtracing this, yes, on backtracing this, the emergent ray, okay, the emergent ray, and the emergent ray is here. On back tracing it, it touches the supposed path of light, okay, here it's touching the supposed path of light here. So here an angle is formed. This is called the angle of deviation, okay. So angle D, very important, angle D. This is the angle of deviation. So what is this angle of deviation? The angle of deviation is the angle formed between the original direction of the incident ray, which is this, okay, this is, so the angle formed between the original direction of the incident ray and the new direction of the emergent ray, okay. So the emergent ray goes in this direction, but what we will do is we will back trace it, okay. On back tracing it, they meet here. So the angle formed between the angle from here, okay, this is called the angle of deviation, okay. So that is the angle of deviation, okay. So I hope it's all right. So this is it, class. It's a small topic. In the next video we will be discussing about dispersion of light, okay, where again we will be studying with respect to prism. So stay tuned and I'll see you in the next video.